Welcome back, everybody. In this video we're going to perform shape detection on still images and webcam video using the hue circles, hue lines binary, fine contours, and approx poly functions in Emgu CV. Today we're going to be using Emgu CV and VisualBasic.net in Visual Studio 2010 Express Edition. However, if you prefer a different environment for Emgu CV or OpenCV development, the code that we're going to use today should port pretty well to any Emgu CV or OpenCV environment. Please see the previous videos for installation and configuration of OpenCV and Emgu CV. Let's get started. Alrighty, so first let's take a look at what we're going to have when we're done. We're going to have this shape detection program. And let's go ahead and fire it up and give it a test run. And here we have the choice image file or webcam. So let's go ahead and choose an image file first. Here's the image file that ships with the shape detection example with Emgu CV. So here we have a square, or sort of a semi-square, and then more of an actual square, and then a triangle and a circle. So here we have a nice detect on the circle, and then because the center of these shapes are not filled in, as we can see in our canny image at the top right here, they're actually detected as two separate images because there's two separate edges, one for the inner and one for the outer. So that's why we have these different detections down here. We have the inner triangle and then the outer triangle actually a polygon because the outside edge of the triangle is a little bit rounded. And then for the top left square here, which again isn't really a perfect square, this area at the bottom here is definitely kind of an extra edge, so that's detected as a polygon, but the inner square is detected nicely, or rectangle rather I should say. And then we have two nice rectangle detects at the lower right. And then this sort of semi-oblong circle is also detected as a polygon. So let's also take a look at the same image. This is simply what we've done is filled in the original shapes here, so we have a nice circle detect, and then two nice polygon detects and a nice rectangle detect. And then we have a third example picture here with a kind of a variety of basic shapes. So we have three circles, those are all successfully detected, and we have a variety of nice line detects. And then we have our three rectangles detected, and those are noted in blue on the lower right image. And then also our four rectangles in yellow, and then our three polygons in gray. So what we've done here to define our polygons is anything with 4, 5, or 6 sides we're calling a polygon. And we check the angles of the object, and if they're 90 degrees or close to that, we're going to call it a rectangle. But in the case of the trapezoid here in red at the lower right, the trapezoid's angles are not near 90 at all, so we're going to call that a polygon. So we've also got this nice filter on color option. So for example, if we'd like to see only the blue objects, then we could do, say, 150 blue, 256, and then for green and red, let's go 0 to 100. And then so now we're only going to get a detect on our two blue objects, the top left rectangle and the right side square, and there we go. And then we can do the same thing for green and red. So let's do 0, 100 blue, 150 green to 256. And there we can see we have three green objects in the original image, and sure enough we have our three green detects. And then we can do the same with red also. 150, 256, and there we go. So we have our two red triangles and then our red trapezoid, and here we are, our two triangle detects and our polygon detect. So let's go ahead and undo the filter on color, and I probably also should have mentioned we can draw the circles, lines, and polygons on the original image with these checkboxes here if we like. And then let's fire up our webcam and take a look at some live images. So I just happen to have a few objects around my apartment here. So here's the first one, is this 9-button keypad. Nothing unusual, or actually 12-button keypad, 0 through 9, and then pound sign and star and 0. So if we go ahead and filter on color, and well, actually first let's take a look at the back. The back has this foam piece here to protect the pins in shipping. That's maybe a better view of it there. So we'll take a look at both the front and the back of this with some different color filtering. So first, without any color filtering, you can see for the most part the keys are detected as rectangles. The back probably isn't going to be detected quite as well. Nope, okay. So let's go ahead and throw some color filtering in there. So to detect light colors, let's start with that. So we'll go with, let's say, 200 and 256. For each. let's go ahead and take another look at the front of the keypad. And now we can see pretty much all the keys are detected at least as polygons, if not as rectangles. So that's pretty nice. And then if we want to change to detecting dark objects, so we can go, let's say, 0 and 40. And that's picking up a little too much background noise in my apartment. Not sure if this is going to work out all that great, but let's look at the back side. And there we are. Okay, that's pretty good. Well, intermittent depends on the angle at which we hold it here, but for the most part we're getting a nice rectangle detect on the foam piece on the back. As for another quick rectangle example, here's a breadboard, just extra breadboard. There's the top, there's the bottom. Let's use the bottom for a white rectangle. So for example, we could do 200, 256, 200, 256, and 200, 256, and enter. And there we are. And as we can see, we get, for the most part, depends on how I hold it up to the light here. Kind of have to get the lighting just right. Background's a little too light to really make this work quite as well as it ideally would. If we twist it a little bit more, there we are. If I kind of hold it to an angle under the light, we'll get a polygon detect out of it. We get some nice line detects. Unfortunately, we're not getting the rectangle detects I'd hoped for. Let's see if we expand our color range just a little bit, maybe 175. And give it another go. And there we are. That's much more successful. Now we're getting some nice rectangle detects in the lower right box. And you can see these algorithms are kind of light dependent. And if you really wanted good reliable results, you'd have to do some other filtering and so on. If we eliminate that object in the background, there we are. Now we're getting a real nice rectangle detect. So it's not perfect, but as far as a basic shape detection to start with, it works pretty well. Next, I've got this reel of fishing line here. Of course, we're not really concerned with the fishing line part of it, but this will be good for a dark colored circle. So let's go 0 and then 40. And there we go. So that's pretty good detect. We see we get a nice circle detect there. Our red circle, we can move it around and it'll track it pretty well. And for a final example here, I have a red fire extinguisher. So we can use that for a red object on a live image here. So let's go 0 to 100 for blue and green, and then let's say 150 to 256 for red. And now we can go ahead and hold the fire extinguisher in front of the screen, and there we can see we get a real nice circle detect. You can move it around, and the color contrasts with the rest of the scene really well, so the detect is pretty consistent and it moves well. So overall, that's working real well for us. So let's go ahead and go back to the still image for just a moment, and so that's what we'll have when we're done. So let's go ahead and fire up Visual Basic and make our project. Alrighty, so we've gone ahead and started Visual Basic. So I think the best way to do this today is we're going to start our project, then we're going to establish our references like usual, and then let's go ahead and fast forward while we put the components on the form. Then we'll slow down while we start each of the functions, and then we'll go ahead and fast forward through all of the functions up to process image and update GUI, the reason being that all the previous functions are simply going to be managing the form. Then when we get to process image and update GUI and we make the actual OpenCV function calls, then we'll go ahead and slow it down again and take a look at things line by line. So let's go ahead and get started. So we'll do new project, Windows Forms application, and let's call it shape detection. And that looks good. Go ahead and choose OK. And let's go ahead and establish our references first. So we're going to go to Project. This is, again, the same as the previous videos. Add reference. Browse. Then we'll go to C. Emgu, Emgu x86, bin. And we're going to highlight our usual 8 DLLs here. And then OK. And let's wait a moment while Visual Basic adds those for us. And let's go ahead and save it at this time. So shape detection, uncheck create directory for solution, it's still going to create a directory for us. We'll save it to our usual Visual Basic directory. That's good. Save. And we're going to go ahead and save that. So now we're going to go to Project, Add Existing Item. And then, whoops, it's jumping around on me a bit here. Emgu Windows x86, bin x86, and then show all. And then we're going to choose our usual starting with OpenCV and ending in DLL files there and choose add. And just a moment there while Visual Basic adds those. And there we are, and save. So now we can go ahead and start populating our form with our controls. Alrighty, so we might come back and touch the form up a little bit later as we go, but at least to get us started, that should be pretty good. Let's go ahead and line our labels up here. Alrighty, so now we're ready to write the start of each of our functions. So to do that, we're going to use the environment to get us started for a lot of the functions. So let's double click the form, and always double check we've named before we double clicked it so the function is named correctly, and that'll start form load for us. And let's go ahead and get the top of our program started too. Option strict is always a good idea. And our imports. We're going to import emgu.cv, emgu.cv.enum, or rather cv.enum. And structure. And lastly, user interface. And then we're going to get into our class. And since we double clicked on the form load's already written for us. And our code's off to a nice start. So let's go back to design view. And the next thing that we're going to do, actually let's write our constructor next. A little bit of change of plans here. Or at least start our constructor rather. So this is going to simply start with, we'll just do sub new and then initialize component. And we'll come back and write the rest of it later. Alright, now we're ready for our functions after form load. So we're going to go ahead and have a form or size event. So let's choose the form, then properties, events. And we're going to look for resize. There we go. And we've got quite a few more events to write for our form with all our nice controls on it. So next we're going to write our radio button for image file check changed and webcam check changed. So let's look for check changed, make sure we have image file chosen. There we go. And now webcam check changed. And there we go. And now we're going to write the form closed event. So let's look for form closed. There we are. And now we're going to write the button click event. Make sure it's named button file. Yep, there we go. So we can simply double click on the button for that. And now for the three checkboxes for drawing the circles, lines, and triangles, rectangles, and polygons on the original image, we're going to do the check changed events for those three. Let's make sure those are all named before we do that. Draw lines on original image. Draw lines on original image. Circles, lines, and draw triangles, rectangles, and polygons on original image. So we're going to go ahead and look for the check changed event for each of those three. And next we're going to start the check changed event for filter on color. Let's go ahead and make sure that's named. Check filter on color. Okay, that's good. And next we're going to write the text change event for the text box. And that's going to give us some nice formatting. We'll see more about that later. Gotta make sure it's named, text file, that's good. Text changed. And now for each of the combo boxes, we're going to write the start of 3 methods: selected, index, changed, leave, and key down. And if you haven't worked with combo boxes much before in Visual Basic, the reason for doing all this will become a little bit more clear later. So in each case, we're going to make sure and check that they're named first. So CBO min blue, min green, min red, max blue, max green, max red. Okay, that's good. So now we're going to choose selected, index, changed for each. Selected index change will be at the bottom, of course, so there we are. Selected index changed for min blue. Now we're going to do the same for the other 5. It's green. Now min red. And now max blue. Max green. And max red. And now back to design view. Save it to be on the safe side. So then for min blue, we're going to do leave. And the same for each of the others. And now same thing for the key down event. And again, if the reasons for this aren't especially clear at the moment, just kind of bear with us here for a little bit. As we get into the code, the reasons will be more clear. And there we are. We only have one more function to start the beginning of, and that's going to be the process image and update GUI function, which of course we're going to write at the end. So sub process image and update GUI, sender as object, arg as event args, and it's necessary to put those parameters in there so that we can add this function to application.idle in the case of webcam use. So now I've gone ahead and started each of our functions, so at this point we can go ahead and fast forward while we write the code to handle our events, and then when we get at the end of the program back down to process image and update GUI and we're writing the OpenCV portion, then we'll slow down and take a look at it line by line. Alrighty, so now we're all set with our code to handle the form, so we can finally get to our process image and update GUI function. Before we actually write the function, let's take a quick look at a game plan as far as how we're going to go about that. So we're going to identify circles, lines, and triangles, rectangles, and polygons. So to start with the easiest case of circles, we're going to start with our original image, then we're going to perform a Gaussian pyramid up and then down smoothing, and then we're going to call an in-place, that's what the underscore there indicates, an in-place smooth Gaussian. That's going to give us image smoothed. Then we're going to call in range if we're filtering on color, otherwise we'll convert directly to grayscale. So that's going to give us image gray color filtered. Then we're going to call hue circles on that. That'll give us circles, which is an object that is an array of circle Fs. And then we're going to call draw to draw the circles into image circles. And then for lines, this will be similar but a few more steps. We're going to start with image original, do our same smoothing. Then we're going to call in range if we're filtering on color. That'll give us image gray color filtered. Then we're going to call canny on that to get our canny edges image. And then on the canny edges image, we're going to call hue lines binary, which is going to give us our line object, which is an array of line segment 2Ds. Then we're going to call draw, and that's going to draw our lines on image lines. And lastly, our most complicated case, triangles, rectangles, and polygons. We're going to start out similar to the others, image original, then our smoothing process. That'll give us image smoothed. Then we're going to call in range if we're filtering on color, otherwise we'll simply convert directly to grayscale. That's going to give us image gray color filtered, and we're going to call canny on that to get our canny edges image. Then we're going to call find contours. That's going to give us our contours sequence. Now, a contour sequence meaning very similar to a linked list. So the contours is an object, of course, but it actually just points to one contour to begin with, the very first contour in the sequence. So what we're going to do is we're going to step through that sequence or that linked list, and then for each case in that list until we get to the null end of the list, we're going to take a look at that contour individually. So the linked list we're going to refer to as contours, and each individual contour that we're looking at, as we're looking at it, we're going to call our contour object here. So then we're going to have some conditional statements to determine, is the current contour that we're on, contour, is that a triangle, rectangle, or polygon, and then we're going to add it to the applicable list with the add function. Or if it's none of the above, then we won't add it to any of those lists. Then we're going to use the draw function to draw the triangle, rectangle, or polygon on our image of triangles, rectangles, and polygons. So that'll be our game plan. So let's go ahead and dive in and get started with our function. So to start with, we're going to get our image either from our image file or from the webcam stream as applicable, and then we'll do some error checking to make sure that we don't crash our program. So at this point we know we have a good image, otherwise we would have returned from the function by now. So we can go ahead and perform our Gaussian smoothing. So now that we have our smoothed image, we're going to go ahead and filter on color if the filter on color checkbox is checked. If not, we'll convert directly to grayscale. And also as a side note, just experimentally I happen to find that if you're using the in-range function to filter on color, it seems to get a better end result if you perform the Gaussian smoothing again after the filter on color, so we'll go ahead and do it that way. Now we're ready to declare our variables for canny threshold, and those are going to be gray objects. And we're going to have 3 of those. And the reason for that is that when we're doing the canny threshold for the circle detection versus the line, triangle, rectangle, and polygon detection, the upper canny threshold is going to be the same amount, whereas the lower canny threshold for the circles versus the lines, triangles, rectangles, and polygons we're going to use a different threshold, which is going to provide us more accurate detection. So we're going to need a total of 3 gray objects to be used as canny thresholds. Now we're ready to go ahead and call the canny function on our gray color filtered image. We're actually not going to immediately use the canny image just yet. And the reason for that is that we're going to do our circle detection first. And the hue circles function is actually 2 steps in one. You pass into the hue circles function your upper and lower canny threshold for circles, and it does the canny thresholding and the circle detection in one step. So later on, we're going to use the canny image when we call hue lines binary and find contours. But that's okay, we can go ahead and call the canny function at this time. So now we're going to call the copy blank function 3 times on image original, and that's going to generate a blank image, circles, lines, and triangles, rectangles, and polygons that'll be the same size as the original image, and then we'll fill in each of those 3 later. So now we're almost ready to call our hue circles function on image gray color filtered. But first we're going to declare some variables to pass into the hue circles function. Then we'll go ahead and call hue circles. Then that's going to return a result of circle F objects in an array we're going to call circles. And then we're going to step through that array and draw each of those circles onto the circles image. And if the checkbox is checked indicating to do so, we'll also draw those circles on the original image. Okay, so now we're all set with our circles, so now we're ready to call hue lines binary, so we're going to follow pretty much the same format. We're going to declare variables for each of the arguments that we're going to pass into hue lines binary. Then we're going to call hue lines binary on image canny, and that's going to return an array of line segment 2D objects, which we're going to call lines. Then we're going to step through each of those lines, and we're going to draw those on the lines image, and if the checkbox indicating to do so is checked, we're also going to draw them on the original image. Alrighty, now we're ready to get to really the most complicated part of the program, but also the most interesting and most fun part of the program, and that's where we're going to discern the triangles, rectangles, and polygons in the image. So to do that, to get started, we're going to call the find contours function on the canny image, and that's going to return our contours sequence, which again is really similar to a linked list, and by default that starts out pointed to the first node. And then we're also going to declare a list of triangles, rectangles, and polygons empty to begin with, and then we're going to have a while loop that's going to step through the contour sequence and then add triangles, rectangles, and polygons to each of those lists as applicable. So now we're going to set up our while loop to step through the contour sequence. So here's how we're going to do that. While not, contours is nothing. And then we're going to have some more statements here. We'll come back to that in a minute, but at the end of the loop, to step to the next contour in the sequence, we're going to simply do contours is assigned contours.hNext. Now we can write our conditional statements to discern if we're going to add the current contour to triangles, rectangles, and polygons. But first, let's go ahead and get the current contour, and how we're going to do that is we'll declare it each time, dim contour as contour of point, and that's going to be assigned contours dot approx poly, and we're going to pass in the variable 10 for our accuracy. Experimentally, that seems to work the best, or at least about as well as anything else with basic shapes. Feel free to experiment with that parameter yourself if you like, depending on what kind of image you're looking at and so on. We're going to make sure that the area of the current contour is at least 250, otherwise it wouldn't be big enough to be a significant shape. Okay, so now we know we have our current contour and the area is at least 250, and we've set up the while loop to go to the next contour. So now we can discern for the current contour, is it going to be a triangle or a rectangle or a polygon? And the first thing that we're going to do is we're going to take a look at the total property of the current contour, and that's the number of points of the shape. So for example, if it's 3, we know it's a triangle. If it's either 4, 5, or 6, and it's 4 with right angles, then we know it's a rectangle, and then if it's 5 or 6 or 4 with not right angles, then it's a polygon. So first, let's separate everything out in terms of the number of points being either 3 versus 4, 5, or 6. Okay, so the triangle part of this inner conditional is going to be pretty simple. If it's got 3 points, we know it's a triangle. So we can call the toArray function of the current contour to return an array of points, and then we're going to simply add those points to our list of triangles. Okay, so now we're ready to discern our rectangles versus our 4-sided polygons versus 5 or 6-sided polygons. So here's how we're going to do that. First, we're going to call the contour .toArray function, and that's going to return an array of points for the current contour. Then we're going to declare a Boolean variable where we're essentially going to suppose ahead of time that the current contour is a rectangle. Then we're going to check and make sure that the current contour has 4 sides and that the angles are at least close to 90 degrees. If it doesn't have either of those, we're going to set the Boolean isRectangle variable to false. If they both are true, then we're going to leave it as true. Then at the end of this conditional block, we're going to add the current contour to either rectangles or polygons as applicable. Okay, so we're rounding third and heading home here. Really all that's left is, at this point, is for each of our 3 lists, triangles, rectangles, and polygons, we're going to draw on the applicable image, that being either the triangle, rectangle, or polygon image, and then also, if the matching checkbox is checked, we're going to draw the triangle, rectangle, or polygon on the original image also. And in addition to that, we're going to take our 6 images, image original, gray color, filtered, canny, circles, lines, and triangles, rects, and polys, and then we're going to update the applicable image box on the form with that image so the user can see the processing steps from the original image all the way through to each of the finished images. Alrighty, so that's going to complete our process image and update GUI function and also our program. So let's go ahead and do a rebuild. And there we go, one succeeded, that's a good sign. So let's go ahead and fire it up and give it a test run. So first let's start with our image and then we'll do the webcam next. So here's our same picture of various shapes from earlier. So there we go, excellent. We've got our 3 circle detects and some nice line detects and all of our rectangle, triangle, rectangle, and polygon detects. So let's go ahead and filter on color. Of course, we still have these options here. We can draw the found objects on the original image if we like. Let's go ahead and check out the filler on color option. So let's filter on blue first. 150, 256, and then let's go 0, 100, and 0, 100. And there we go. There's our 2 blue objects, rectangle and triangle, nicely detected. So now let's test out filter on green. Oops, meant to do 150 there. And there we go. There's our 3 green objects. The polygon at the top right, triangle, and the circle are all detected well. So now let's go ahead and test out filtering on red. And there we go, our 2 red triangles and our red trapezoid are all detected well. So excellent, this is going great so far. Let's uncheck that and try out the webcam. And as another example, let's go with the 9-button keypad. And then of course on the back we still have the black foam. So let's go ahead and filter on color. Let's filter on a light color first so we can do the front of the keypad. And hopefully we'll see our keys detected as rectangles. And there we are. There's some excellent detects. It's detecting all of them. How about that? And then we can go ahead and use the black foam piece on the back to detect a dark object. And there we go. We're getting a nice, very nice solid rectangle detect on the foam piece. So it looks like this project is a definite thumbs up. Congratulations! You now know how to perform shape detection on still images and webcam video using hue circles, hue lines binary, fine contours, and approx poly functions in Emgu CV. See everybody next time.